All right, are we all here? You can see this? I'm gonna assume so. All right. So what can AI do for my business and what is it? So I'm gonna start off by explaining what artificial intelligence is, and then I'm gonna give a few examples, and then I'm gonna start flirting with how those examples and those ideas can move us into the business perspective of how we can utilize these in business and industry. So what I want to do is I'm going to start off with the purely academic definition, right? To make sure that you guys know that this is about as foundational and rigorous as we can start from. And then my goal is going to be to make this make perfect sense to all of us, right? So this is pretty much the textbook definition of machine learning that you'll find in many different books cited by Mitchell from 1997. A computer program is said to learn from experience, which we call E, with respect to some class of tasks and performance, if the performance at that task, as measured by the performance P, improves with experience. So these are the three fundamental components that I want to impress upon all of you to keep in mind when you understand and interpret machine learning. If you understand these three things, whenever you're discussing with pure academics all the way to business people, these are the concepts that are going to be most important to understanding the discussion that you're having. So what are some examples? So experience is a general concept that we use to basically represent information, data sets, feedbacks, different representations of data. So experience is essentially any sort of information that you can ingest or get back from some process. Now the tasks are extremely general. You can imagine this to be anything that you've seen: facial recognition, translation, like Google Translate, or credit card fraud. We're all grateful for getting calls when suddenly our credit card number is used in some obscure country we've never been to. And all of these are tasks, right? And then we have the performance measure. And so this is something such as accuracy or error rate. And this can often be pretty difficult to choose. And so these three components give us the foundation for understanding any machine learning algorithm, okay? You have some task, and the goal is that your ability to perform at that task gets better as measured by your performance as you experience more things and you get more data and you get more feedback, all right? So let's go ahead and dig in a little bit more into what these concepts are. So the most important thing to understand to do this is to know what a function is. And so I just think conceptually it's really good to think of a function as an input-output machine with knobs that you can turn. All right, so the knobs are what we call parameters, and this is the key to understanding how machine learning learns. You have some function with parameters. You're going to have some input that comes into the function, and then you're going to have some sort of output where that input has been transformed. So in here, the function is our task, okay? The input is our data, and then our performance will basically be how we compare the output to something else, which we haven't talked about yet, but we'll get to. So all three of those components are here. The task is the function, the input is the data, and our performance is basically what we compare the output to. And now as we tweak the parameters of our function, then the output is going to change. And the goal of machine learning is to find the optimal setting of these parameters such that the output does exactly what we want it to according to our measure. So if this is sound, then we want to find the optimal setting of these knobs and buttons here such that the output sounds perfect. And when humans do that, that's basically machine learning in the human brain, right? It's human learning. We're finding the optimal setting such that the output satisfies what we want. Now we just want to extend this concept to machines, and that's machine learning in a nutshell. So that performance, that cost, how does that translate to more complex things? Well, neural networks are just functions, okay? All of the little connections and weights, those are the parameters, just like we saw before. These are the knobs and the buttons that are on that the mixing control panel that you saw. And just as before, we're going to have some form of input that comes into the algorithm, and we're going to tweak and change those parameters such that the output satisfies whatever we want, right? We can define whatever performance we want, and by tweaking the parameters, eventually it will conform to our expectations here, okay? So the cost function, what does that mean? What is this performance, this cost? Well, this is really a high-level concept that I just want a high-level figure to communicate it to you. So every single point on this space here is going to be a particular configuration of those parameters that you saw before, the knobs and the pulleys. So every time you grab a new point on here, it's a new configuration of the parameters. And the goal is to find the space on this surface here where the configuration of the parameters corresponds to the lowest value, because this is your cost, right? So you want the cost to be very, very low. It's basically measuring how well you're doing things. So the error will be really, really low when you find a spot on this surface where the configuration of parameters gives you a low cost, okay? So this is essentially the optimization step of machine learning. And these are all the different algorithms that you might choose for the optimization step. And the goal is always to choose the one that wins the race to the bottom, as I say. So when you're first coming into this, you have the experience, which is the data. You have the task that you'd like to perform. And then you have the performance or the measure. And this surface gives you that here. And so you're going to move all the way down to the point on this surface where the parameters give you the lowest cost. And those are the parameters you want for your network or your task, your function, to do the job optimally for you, okay? So let's jump into an example. So what I'm gonna show you here is machine learning in action. We're gonna watch it happen, okay? So this is gonna be the experience, the task, and the performance. The experience is gonna be data that we're going to acquire from people out in real life. The task is going to be based on the data that we get from people. Can we determine whether they use an Android phone or whether they have an iPhone, Android or iPhone, right? And then the performance is going to be classification. So we have the labels of which ones they use, and we want our algorithm to be able to predict which one they use based off of some measures. So what measures are we going to have? Well, what we did is we went to a couple hundred people here in Tallahassee, and we measured their intelligence on an IQ test, and we measured how attractive they were, and then we asked them what type of phone they had. And this is the scattering of all the points here. And as everybody obviously knows, everyone who uses the iPhone are both attractive, or Android are both attractive and intelligent. And then if you use the iPhone, unfortunately, as we all know, you're probably not attractive or intelligent, right? So while humans know this, we want to try and teach our machine this, right? So how do we teach that? So what we're going to do is use a very, very simple neural network, and it looks just like this, right? The input is going to be the intelligence of an individual and how attractive they are. And then the goal is, can our algorithm predict whether they use an Android or an iPhone? So we're going to initially set the parameters P. Remember, this is like that mixing machine. These are the knobs, okay? And it's set to P1. So this is where they are currently. And if we just have it guess as is, this is what it thinks, and it's doing a really bad job. Everything on the left is the iPhone, and everything on the right is Android, and it's doing a terrible job. So it needs to start learning. So how do we do that? Well, what we do is we randomly take a bunch of examples and we put it through the performance function, right? We say, how well is it doing currently? Well, these ones over here in the green section, it is classifying correctly. And these blue ones over here in the white section, it's classifying correctly. But all these red ones, it's classifying incorrectly. So what we do is, using that optimization step, we actually update the parameters, right? So now we have P2. So we basically looked at the performance and found a way to update the parameters P2 such that it does better in the future. And now if you see, the line twists a little bit and it's doing a little bit better. And so what do? We just continue. This is the learning process. We grab more data at random, we measure how well it's performing, and then we update the parameters once again to P3. And then it got a little bit better. And machine learning is this over and over and over again. So if we just let this run, it just continues to run here, as you see. This is what it's able to learn. So this tiny little neural network right here with just 2 nodes going into a single classifier node, if I let this run and run and run, this is how well it's able to do. Now, those among you might say, well, it's not doing a very good job because it can't seem to classify these green ones correctly on the edge or these white ones correctly here. And this is where I'm going to sort of stop with the theory, but I want to give you just a little bit of insight into why depth is important in neural networks and why this deep learning notion came into existence. Because when you add depth, for example, if I do one more layer, suddenly my network, my function, has the capacity to learn what is called nonlinearities, right? And so it transforms the input space into something that it's able to solve. And so see, now it's able to bend and learn to classify things better. All right, and so the more layers that you add, the deeper it gets, the better it becomes at being able to classify things. The more parameters it has, the more expressive power it has, the better that it can fit to your data and the better it can solve your problem. All right, and so this is the machine learning process in a nutshell. The experience is the data. the task is classification, and the performance is how well it's classifying. And we just go through this loop over and over and over again, and we slowly update the parameters until it does the task very well. All right. So let's go to just a few examples. These are applications that you can use this concept and do lots of things in the world. So at Newsci, we try and offer what we call insight as a service. So using machine learning, we try and go to businesses, companies, and help them understand how they can utilize this technology in many, many facets. And some of the main ones that we operate within is the natural language processing world. We do a lot of image processing, semantic image segmentation, classification, object detection, anomaly and pattern detection, looking for outliers for companies that are just trying to monitor performance of certain systems, and then recommender engines, which are very popular. And using these, you can glean insight into many things to improve the experience for your customers or optimize expenditures, etc. So just as a brief example, natural language processing, I think, is a very interesting topic. And so I'll use it to go into a little bit more depth. So what I'm going to show you is basically the entire universe of natural language processing research in one figure. All right. So you have somebody who speaks. This is the generation of language, right? The brain just comes up with some representation for an idea, and then through the majesty of speech, we actually just create little pressure waves in the air that communicate this concept in language. So the whole first part of this process in machine learning is what's called speech recognition. So can we take this this wave, the speech pattern itself, and then recognize or identify the text that the person is speaking? Now, once we've got this text, what do we do with it? So the second branch of research is called natural language understanding, which says, given the text, can we somehow extract meaning, content? Can we identify person, places, things, named entity recognition, parts of speech tagging, etc.? Now, once we have meaning, the concept, this is like the idea in the brain, can we now generate new text? And this is natural language generation, right? So can I somehow create text that represents ideas or concepts, new text, right? And this is natural language generation. And then finally, given that text, can I then synthesize new speech? And then this is speech synthesis. So this is the entire pipeline of communication. And these are, each one of these little bubbles in here, you can get a full PhD on and do decades of research in, and it's very exciting. And we dabble a little bit in all of them. And in fact, one of our services is actually this full pipeline here to try and create a simulation experience to help people. So this is a really exciting area of research, and any one of these components can be used to enhance any of your products or services or customer experiences. Another really popular one that people like is document digitization, right? We've all got these filing cabinets of old documents, and we'd like to get them onto a single computer so that we can do processing on them, right? Once we have it in text form, then it's amenable to analysis for natural language understanding and furthermore. Then we also have recommender engines. So these are very popular. There's a notion of content-based filtering. So what this means is that if you're a user and you buy something, what you can do is search through all of the other products that you offer and find something that is similar to this product according to your measure, your performance of similarity, right? And that's part of the research, is how do you define what is a similar product? But once you find one, you recommend it. And so this is content-based filtering, where you filter recommendations based on the content themselves, based on the products themselves. Another one is what's called collaborative filtering. So here you recommend things, rather than finding similarity between the products, you find similarities between the users. So this individual buys whatever, pizza and salads, and they like mushrooms and vegetables. And this person is also sporty, and they buy pizzas and salads, and they just so happen to like this beverage. So collaborative filtering suggests that because these two people are similar and they like similar things, then it's probable that this other person would like to buy this product as well. And so this is collaborative filtering, where you're recommending based on the mutual interests of individuals versus just the similarity between products. All right, now the most successful recommender engines are some combination of these two. And actually, very, very recently, we've even moved away from these, where we use very deep learning, machine learning algorithms to get what we call representations, and we actually learn recommendations in these representation spaces. But these are still very popular and common techniques that you can use to recommend things to your clients. So the next thing I want to show you is how this is done in industry, like in practice. How do you do these things? And the key to do this is going to be data. So I want to just sort of impress upon you how important data is, and then that'll be where David takes over. So this notion of speech to text, we all take advantage of it on our phones, Alexa, Google, Siri, etc. How does this work? Well, it turns out that all of these algorithms, hidden Markov models or, connectionist temporal classification networks, these have a lot of parameters. And to learn the optimal setting for those parameters, if you recall from the beginning, it's just those knobs and buttons. To find the optimal setting requires a mountain of data, okay? So these algorithms can be very data hungry. So when you speak into your phone and it identifies what you've said, that algorithm has been trained on over 50,000 hours, or roughly 5 years worth of somebody speaking, right? That's a lot of data. What about natural language processing, right? So there's a lot of really interesting things that have happened in this universe here where these algorithms actually learn semantic similarities between words. King is to queen as man is to woman, or walking is to walked as swimming is to swam. So it learns these things, but how does it learn it, right? Well, it turns out that as of a little over a month ago, GPT-3 is the world's largest natural language processing algorithm. It's what we call a language model, and it has over 175 billion parameters in the model. And this is an order of magnitude larger than the previous model, which is called the neural Turing machine. And this was trained on the entire Wikipedia database. And more. It needs all of the examples of how we use language in many different capacities to try and extract the idiosyncrasies and the statistical relationships of all the words to know how to learn these things. And what about images, right? We see this all the time. Facebook finds faces for us, so we can do object segmentation, classification, etc. Well, as of 2019, many of these state-of-the-art architectures here, you may have heard of some of these things. Google's Inception network, or AlexNet was the groundbreaking network that came out in 2015. That was all exciting. Currently, HRNet is the current state-of-the-art architecture. These are trained on over 18 million images, and this is as of 2019. This is the largest database as of 2019 for training these image processing algorithms. So you need data to do this. So what I'm trying to emphasize here is the significance of data and how this should shape your perspective of how you employ or think about machine learning in industry. So I summarize this here with this following sort of corporate strategy for businesses. So whenever you're creating something new as an entrepreneur, you have to create a prototype, a proof of concept, right? But in the AI or machine learning world, your philosophy should go according to this. You have a prototype that's good enough to get some initial users. These initial users then give you more data, right? If you've designed your application correctly, everything your users do when they're interacting with your service or your product, you should be extracting data for them. They're giving you labels on things they like to click on things that they do. You're getting data from them. With this data, as you just saw me show you, you can improve your algorithm's performance, and you can even offer new services that you might not have been able to before. And once your service gets better, well, guess what happens? You get more users. And then as you get more users, you get more data, you improve it, and you get more users. And this is the synergistic cycle that you should think about when you're trying to consider how to broach the new machine learning entrepreneurial world. Once you get into this cycle, your business becomes extremely defensible because your mountain of data is something that Google or none of these other companies can come and defeat you with, because while they may have great machine learning algorithms, if they don't have your data to train them, then they can't compete. So the data itself is really where the power comes in. That's where the value is in the new machine learning and AI world. Okay, so what I'm going to do from here, I hope you all appreciated that and understood the idiosyncrasies involved in sort of machine learning, how it works and how we think about data. And I'm going to punt it over to David now. So let me stop sharing, and then David is going to take over and share with everybody how we can incorporate these ideas into new business strategies and how you think about it from the business perspective.
Thanks, Nathan. And one of the ways that we got to be friends was I heard him do a talk, now I guess it was 3 years ago or so. And even though Nathan is incredibly smart, he genuinely wants you to be smarter after you listen to him. Whereas I find some people with that kind of knowledge can actually just want you to think they're smart. So that's what I went up and I said, wow, get people comfortable, because what I want to say to everybody, for some of you, you might be like, hey, I'm comfortable. For other ones, you're like, this is scary. very reminiscent, for those of us on the call that can remember this, the 80s, the adoption of computers across industries. And what happened in the beginning was a lot of people were not comfortable. They didn't understand the fundamentals of how a computer worked. So there were a lot of just, you know, either silly expectations or they didn't understand its potential. So I really would say to all of you, it is worth understanding the basic concepts. Only some of you would I go down any one of these rabbit holes, okay, because they're very deep and we're only at the beginning. But let's step back. You know, Domi's for startups, and you know, I'm a serial entrepreneur. This is a look at the 2020 AI startup landscape. And the biggest thing you should look at is all of the different industries that are now adopting it. When we started NewSci in 2013, very few industries were in this game. Healthcare was an early adopter because it made sense. They had a mission critical path. They needed to be able to, for instance, see on a mammogram a cancer. And they had a lot of data, back to what Nathan said, got a lot of mammograms, right? Got a lot of digital data. So they had a lot of data. They had a high return, potential high return on that insight. But what's happened, especially in the last, it's really accelerated in the last couple of years, is every industry is saying, wait a minute, I can use this. Maybe not, and we'll talk about this, maybe not to change everything I do, but perhaps to change part of what I do. And I will say to any business owner, if you don't have a plan for AI, then you've basically got a plan for obsolescence. Because I can remember in the 80s arguing with people who thought that databases were not for them. File cabinets were fine. So with that said, and you know, we've got Matt on the call who's an investor. Why are they so interested in this area? Well, you know, what it always comes down to is money. This is how big they think the AI market will be in just a few short years. This is as transformational for the industry as the processor, you know, as you look in that kind of late 70s into early 80s and that sort of information age period, which in the beginning people were like, well, that's just games and it didn't seem all that relevant, but you know, who now, what business can live without it? AI is experiencing that, but it's experiencing it even faster. So if you're thinking about a startup, keep thinking about it. One thing that I will say, we're obviously in the middle of a horrible time where we all feel like we're living in a science fiction movie in so many ways. The irony for startups, this is the best environment for a startup. The best time to start a business is when the normal world, the stasis, has been shook to its core. When Microsoft came around and Apple came around, we were deconstructing manufacturing in this country. A lot of fundamental businesses were changing. It's where the tune Born in the USA came out of. It was very depressing. You know, I graduated high school in the late 70s. I was told I'll be the first generation to make less money than my family. And what they should have said was, you're going to have to make money differently. And that's what I would say to people today. It's not that what's happening isn't going to destroy, in some cases, some types of businesses, but whole new businesses will be birthed out of this. So let's look at some business models. The first one, and it is the easiest, is what's called a bolt-on. So this is when you take a piece. So let's go back to the computer. You know, you could have been IBM and tried to build the whole computer, or Apple, right? Or you could have taken an element of that. Maybe it was just the floppy drive. Maybe it was, and I know people are like, what the hell is a floppy drive? But there really were floppy disks back then. You know, you take a piece, you know, there was a modem back then. That was what communicated with it. So you take a piece. Well, the AI version of that are things like this. So this is a thing called, I think it's called Coquito. And what this does is, while a salesperson or a customer service person is on with a customer, it's monitoring how that's going. What's the emotion in the call? And it actually says, like, you're losing this person, or they're getting angry, you need to de-escalate this, or maybe you're getting angry, right? And, you know, a lot of, it's what's called active listening, where you're really trying to mirror people. And this is what it's doing. But this is meant to be used with something like Salesforce. It's not meant to be Salesforce. That's what I mean by bolt-on. It's a piece of a larger puzzle. As an entrepreneur, I will tell you this is the easier path. Whenever I have someone to come into Domi and they say, I'm going to build the next Facebook, I go, okay, because, hey, in the end, Zuckerberg had to build Facebook when there was Friendster and MySpace, and Google was the 201st search engine. But that's the hardest path, to say that I am going to take an entrenched group of people and I'm going to take them out. You're going to need siege guns for that. Much easier is say, where can I add value to an existing system? Now, the next one is an enhanced process. And this is the one to look at if your business, like you're like, I don't want to build an AI app. I just need my business to be better. This is where a lot of businesses across many industries that you don't think of as AI in any way, they're already using it. So the most kind of famous example, well-known, is Netflix. Netflix, they are a combination of a movie studio and a television production operation, and you know, like CBS, NBC. So they buy programming, they create programming. The problem Netflix ran into was there was too much. There was no way to just classify things by what they were, comedies, dramas. They had to find a way to put in front of us so they knew that, like, I like Schitt's Creek, you know, The Great American Baking Show, The Office, The Dairy Girls, and Babylon Berlin. That's a pretty interesting matrix of things. But the fact that I watch those now tells Netflix quite a few other things. And in fact, at this point, I've been watching Netflix for a while. These all came to me because of other things I had watched or my wife Lori had watched. So the other thing about Netflix is Netflix actually uses AI to select what shows to produce. So they've actually, so not only at the end what to recommend, but actually what to produce. Now, what about Walmart? Now, Walmart is Walmart, right? They sell you groceries, they sell you stuff. They're a store. But in fact, Walmart was an early adopter of AI because they load their trucks using machine learning. So they're not humans. They actually say, you know, Tallahassee, the Bradfordville, you know, Walmart needs, you know, Crest toothpaste. That's not a human making that decision. But one of the things Walmart just did, and this goes back to what Nathan said, they have already started an AI-powered store. So why would they open that up? You actually can go in it. And when you go in it, you actually just shop. But what they've done is they've done things like they know when something's out of stock. So they've put sensors in there, which then when that's out of stock, goes right over to the person who restocks in real time. And by the way, communicates the current inventory back to headquarters to know what to load into that truck. So they could have waited till, well, let's wait till we get everything, this AI thing, you know, whatever. No, I want to let some customers in here. And it's actually one of the most popular stores. This has got a lot of cool stuff in there because what they wanted was we need to get data in here. We can't have this abstract because a lot of this data didn't exist because these sensors aren't in the other stores. And then the final model is, well, what if it does everything? What if you did build truly an AI business? So the business is going to be an AI version. So I'll give you an example in the old world, Salesforce. Salesforce took the idea of software, which was always licensed, right? I'd pay you a license and you gave me, you know, back in the day, you got it on like a CD-ROM and then you loaded it in your computer. And then maybe I paid you some amount every year to keep it up to date. Well, all of a sudden, Salesforce came along and said, what if you rented the software. And now we all know this is software as a service. And unless, if you're young enough, you think that's always the way we got software, because that seems obvious. Why would I own this thing? Why don't I rent it? Let you take care of it, all that. But at the time, I want to be clear, when Salesforce came on the market, they thought they were insane, because they actually lost money for a number of years in order to ultimately make huge money, because they had to build it up. Same thing's true with AI. This is exciting to say, I'm going to totally disrupt, but again, this can be a lift. And so make sure you pick where you're going to go very, very well. So I'll give you an example. Here's one called Roofer. So to get an estimate on how much it's going to cost to replace your roof or repair your roof, they have to come out to your house. And they go up on your roof and they look at your roof and they measure everything, and then they come back and give you an estimate. Well, that's very costly, very cumbersome. And also means I've got to call somebody, have them come out, and maybe I go, I just don't want to mess with it. Well, now you go to Roofer, all you do is put in your address, and all of a sudden that, by the way, is a satellite image of Domi. It automatically, using machine learning, can measure that, can also judge the condition of the roof, and then can give you an estimate. And all you do on this site is answer a few key questions, and voila, you have an estimate. So this is an example of really changing the game. Because of course, what Roofer's really all about, to be clear, is they'll then control who gets the leads. And that's a very lucrative business. So what are the benefits for you? Okay, well, an obvious is you're going to increase the productivity of your people. So this is augmented intelligence. And that's something we haven't really hammered on yet. There is no such thing as artificial intelligence, okay? Nathan, let me know that very early on, in case you're one of those people. That's way out there. We are at the beginning of that. Augmented intelligence, which is really elegant programming combined with really amazing math, combined with incredible processing power, combined with a lot of data, is doing what's happening now. But this is augmenting the intelligence of humans. We're not where we can replicate 100%, a human with all the nuances. Don't underestimate the power of the generalist. You can add value to existing products and service lines. This is an area where you don't say, well, I'm not going to, I got to think of something totally new. It's not like Netflix reinvented entertainment, okay? They didn't, I went to Blockbuster, right? Why Blockbuster wasn't Netflix is beyond me. That's a whole nother Innovator's Dilemma webinar we can do. But bottom line is they didn't invent the space. What they did was they reinvented how they were going to both deliver and give us our choices. Obviously, you can create new products or service lines. So if you're an existing business, maybe you'll have some AI piece, but you don't get rid of all your business to do this. You also can glean insights. If all you do, let's say you're sitting on 20 years of customer data, or 5 years of customer data, to be able to go in and really understand. Because one thing I want to be clear that Nathan talked about with data, and you heard all those numbers, it isn't necessarily that you don't need that amount of data, okay, to do something like if we have 5 years of your customer orders, there's a lot that can be done with that, okay? It's just that to crack some of the bigger problems, you're going to need ever more data, and you want to enhance your ability to collect and store that information. And then finally, this idea of providing prescriptive analytics. Everybody's heard about analytics, but what this means is it actually recommends an action and potentially does the action. So I'll give you an example. Let's look at, we all driverless cars and everybody's like, I don't know if I get in one and everything. Here's the reality of AI. It's all around us. We've had driver assistance for quite some time, things like cruise control and such. We've had partial automation where it's allowed at moments to do like automatic braking. It's allowed to do a few tasks, but the human's still there. Now, all of a sudden we say, well, maybe I will let go of the wheel, a little bit. I'll let you do this. Maybe I'll let you park the car. I'll let you do a little something, but the driver is still there. The fourth level is, well, go take me downtown. But true automation, that final level, is actually where the driver's not needed at all. And in fact, in Sweden, there are driverless trucks. And you notice there's no place for a human. Most of the pictures you see of driverless cars and driverless trucks actually still have a seat for the driver. But my point for businesses and startups is there's tons of AI value for you along all of this continuum. And in every industry, you could do the same thing, where you could say, well, maybe, we're not at this full automation point, and that might be years away, but maybe we're on step 2 or 3 or 4. Plenty of money to be made in those steps. Is your business ready for AI? First off, do you have data? I mean, when Nathan and I work with clients, number one way that something fails is the data either isn't there or the quality is just too bad. So we've got to fix that first. Is the data, like, you might think it's relevant to your problem, but in fact, when we look at it, the way maybe you've collected it or what you've collected, actually we don't have all the relevant information. Do you have a clear understanding of what you want to do? Nathan talks about, a problem clearly stated. You're halfway there. I got to tell you, a lot of business owners cannot clearly state what it is they want to accomplish. And to be fair, it's hard. It's a hard thing to really understand what you're trying to do. Also, what are your internal capabilities to do this? This is the build or buy, and that's an important decision, and sometimes it might be hybrid. My advice to you is, if it is going to be central to your business for the long term, so not like a little improvement, that kind of thing, then you need to think about having your team. But if it is a little thing, be careful, because the team you need to get you, it's like a first stage rocket. Has a lot more thrust than the rockets when you're in space. That's how it feels in these projects. So what I worry about sometimes is you're going to be in space, you're going, hey, this is great. Why do I have this first stage rocket still attached? And then finally, is the ROI high enough to warrant the investment? Like that roofer, they had to look at the market for roof repair to say, was it worth whatever it cost them to build that? Because ultimately, if whatever you're going to sell doesn't have a high enough value, why should you bother? And then this is just, kind of to tease you, why is this important in data? So this is a company called Blue River Technology. It was literally just some students. I know we have some students on here. I believe they went to Stanford. And they went out in the fields and they took pictures of good vegetables and bad vegetables. In this case, I believe it was cabbage or lettuce, one or the other. And it was just, all they did was, good ones, bad ones. And they trained it to be able to do that. And they actually then got tractors to go over and all that. Well, John Deere came along and said, I will pay you $305 million for that data. And you're thinking, well, why didn't John Deere, with $305 million, couldn't they go out and take their own pictures? The thing is, it was worth it to them to get the neural network that had been trained on all that data than to start at zero and try to catch up. Because what they knew was if they didn't buy them, then their competitor would buy them. And those people would have a tractor, because now John Deere tractors actually have these attached to the tractor. And it actually, as you go across, is analyzing it. So a couple things to remember. You saw the data, the product, the users. Strategic data acquisition. You've got to figure out, what is the data I'm going to need? How can I improve the data that I'm acquiring? You need some kind of unified data warehouse, or if you want to talk big data language, a data lake. It's just a place where you can put this together and be able to deal with it. Automation, one thing I got to tell you, AI never stops. You don't like lock your code and then you're done. It always learns. And then the other piece is the job descriptions. This is all changing in real time. So you may have people on your team who could be upskilled. You may have people on your team that are doing certain functions that fall in this category, that now we're going to automate that part of your job, but now I want you to do this other part of the job. Because back to driverless trucks, let's say they're all driverless. A lot of us think that that means that truck drivers, you know, everybody will be out of business. No, what's going to happen is, you may not realize this, there are more drone pilots in the military than there are pilots of actual planes. What's going to happen is you're going to have people in command centers with those driverless trucks monitoring those. So it's a new kind of job, and it doesn't require you to be there. And frankly, it's awfully nice because you don't have to go all around the country, but you still are going to have a lot of the things that are in the head of a truck driver in order to do that. So whenever when I hear about, oh, these jobs are going to be lost, I'm like, okay, but you haven't accounted for all these jobs that are going to be created out of this and how this is going to be in a different world. So with that, we're opening it up for questions.
Gentlemen, I would like to thank you for a fantastic presentation. Both the simplicity at the top level and then the detail provided and very specific examples. So that was incredible. I will, in spite of my temptation to ask lots of questions, I'll let the group ask a few questions. I will perhaps suggest a future topic and that would be ethics and AI. Particularly, you talked about driverless vehicles. That's one of the examples. I came out of the media space, and so speakers listening to everything and perhaps making suggestions with an ulterior motive. So I'd love to invite you back and talk about ethics and AI at a future date. So thanks again, and I think Harley's going to tee up a few questions in the remaining time.
Well, and thank you, Bill. And just so you know how important we think that is, Nathan and I believe in that. We actually have in a separate track a lab that's just dedicated to the ethical adoption of AI. So we would welcome the opportunity to come back. So Harley.
Okay, first question from William McCarthy. How are small businesses managing the mountains of data required to improve their services in the updated corporate strategy?
Well, that's kind of two. Nathan, maybe I'll take sort of at a high level and you do the technical side of it. Well, I think data acquisition and data management are just central. You know, they talk about data as the new oil, but what AI does is it turns that oil into plastics. In other words, it extracts value from it. So it has one value when it's just sort of sitting there, and it has value, but that ability to go forward. The infrastructure, which maybe Nathan, you can talk a bit about how some of that can be rented, sort of the software as a service. You don't have to have your own data center for every place.
Yeah, I think it's really important to identify what it is that you want to accomplish with the data. So you have the bare bones, like a garage that you put your car in, that's fine. But you know, the type of garage and where the tools are, maybe the car parks over top of a car lift because you're planning on doing work in the car, or maybe you just want to store it there but never do any work, right? So the exact details of the garage or the data warehouse depend on what you want to do. So you know, we can talk about that if you're interested in the future about some of the actual technologies, you know, BigQuery, Bigtable, or the different ways that these are stored in the cloud. And those are important. But it's also important, what do you want to do with it? I mean, are you going to use it for a machine learning application? And if you are, then you're going to say, well, what labels do I need for me to be able to use it for this application? So you want to store it in a place that it can be easily accessed. You need to put it into a database where labels can be associated with it such that the subsequent operations you apply to it are going to be easy. So you want to do a little forward thinking in how you're going to want to use it. Yeah, I would be happy to chat with you about some of those details if you're interested.
And in the recap email, I'll put David and Nathan's LinkedIn. So if you want to connect with them after this, if we don't get to your question, you'll be able to message them on there. And then from Ashton, how often are your AI algorithms built from scratch / completely custom, and how often do you use existing libraries?
Yeah, so that's down my alley. That's an excellent question. And pretty much in general, there's the two factors is what does the client want and how much time do we have? So if the client just wants a service and they just solve this problem for me, and that's all they care about, then we just solve it as quickly as we can. You know, there are many existing algorithms and architectures out there, and we have a full repository that allows us to just take their data and pump it through like all of the latest and greatest algorithms, see which one performs best, and then we solve their problem for them as quick as possible. And that's one particular avenue. Another avenue is this company, they actually want their own architecture. They have very specific idiosyncratic needs. And when we're really lucky, it's never actually been solved before, which then we get to do some of the research, which is our favorite part. And then what they really want is that this model and this data becomes sort of a pillar of their company. And during acquisition time now, suddenly they're an AI-enabled company and they have this, you know, just like the John Deere example, right? So it just really depends on the company and exactly what they're trying to accomplish. If they just want a service, we'll use the data that's there and we'll get it done. But if they want it to be a part of their company, we'll try and customize it to their needs.
And then one more question, we'll have to sign off because I want to be respectful of everyone's time. Again, from Ashton, what AI applications are the most open to implement? Like most open source libraries, documentation, community support, etc.
Yeah, that's another good question. So the two that we use, and from my experience, they have the most adoption, the most use case, the most documentation is PyTorch from Facebook AI Research. It's a Python library that is just very, very well developed, has a lot of resources to it. And TensorFlow, which comes from the Google Brain project and Google AI. Both of those infrastructures allow you to utilize GPUs. They have a lot of pre-trained models that are baked into the services, so you can just automatically use their pre-trained model and you can modify it and you can fine-tune those models is what it's called. And then applications are open to implementing. So I think that the easiest ones to adopt are going to be computer vision algorithms, such as like MNIST and the classification algorithms. Those have been around for a long time. Everybody and their friends and their relatives has written a blog about how it's done. There's tutorials galore, and that's a great place to just jump in and get started. PyTorch and TensorFlow have all of those things already implemented. You can just run a program with a few lines of code and you're already getting started. So applications would just be simple computer vision classification tasks, and then the libraries and open source tools to use that would be PyTorch and TensorFlow.
Okay, we're 1 minute over time. I want to thank David and Nathan again for a great webinar. Again, this is being recorded and I will include their LinkedIn so you can connect with them afterwards if I didn't get to your question. And I hope everyone has a wonderful day. Thank you again, Nathan and David.
Thank you. Thanks everybody for joining us.
Thanks, everybody.
Stay safe and well out there.
Thank you.
Thanks, guys.